Okay, welcome again to the third part of. Oh, I spelled architecture wrong. Like, this is so awkward. Architecture. Yes. welcome to the third part of this little mini series, Rhino basics and stuff. You know, we went through like the first part. You know, you familiarized yourself with Rhino. There's like a bit of an example drawing. That was really long. I probably made it too long. I should have done like a simpler household object. Yeah, anyways, today we're gonna learn 3D objects, commands, and then we're gonna do like a little make 2D drawing of it. We're gonna scale it, export that to Illustrator, whatnot. And we're gonna talk about sort of solids and sort of the ways you can manipulate solids and the type of geometry that solids are, which is also important. And we're going to talk about a bit like the theory as well. So let's just let's get into it. Okay. So the first thing that we're going to talk about is surfaces, right? So where's my little list? Okay, so surfaces, there are trimmed surfaces and untrimmed surfaces. And so untrimmed surfaces are like, let's say if I were to, draw a surface, I type plane, and like I just draw like a flat planar surface. That if you type what, right, into the command bar, Rhino will tell you what it is. It'll give you the information on that object. So you can see the object ID, the name, and then you can look at what type of geometry it is. And so here it's a valid surface, right? It's a plane surface. And it's pretty straightforward like that. It's literally just a flat two-dimensional surface. Okay, and then you have a trimmed surface over here, and you can see it's trimmed because it got holes and whatnot. Like if you were to cylinder, I cannot type today. If I were to like draw a cylinder, and why is my oh no, I messed up. I'm so sorry. I am just fat fingering everything. So if I were to draw like a cylinder and like use it to like cut holes. Oh no, not Boolean Difference. Okay, I am like, my brain's not working. If I were to use it to trim like a hole, that's essentially what it means. It's a trim surface. That was such a long explanation. But you can also untrim these surfaces because Rhino keeps sort of the information on what this surface was before, right? Like the history. So if you untrim, you can be like, I restore you to your previous state, right? And you can get rid of the holes. And ta-da, back to normal. And so that's trimmed and untrimmed surfaces. Now we're going to talk about B-reps. So this is an extrusion, but it's also, B-reps are sort of like a more, how do you say, B-reps, it's spelled like this, it's B-rep, B-R-E-P. And it's essentially a short form for boundary representation. And what it is basically when one or more surfaces are joined together. So you can have open B-reps and you can have closed B-reps. Like for example, this box over here is a closed B-rep, right? It's also called an extrusion. But like, let's say if you were to explode this, it comes out into a bunch of different surfaces. And this is also like another trick that a good thing to do is that if you are working with surfaces and these things, like if you go to your display panel, if you go to like panels, there's one for display, and then you go find your display panel, there is a setting that is object settings where you can color back faces, and you can choose the back face color. And I usually set it to like dark gray so I can like see what the side is different, but this allows you to tell like which side the surface is facing, because surfaces have a direction, right? So if I type dir here, it'll tell me the direction of the surface, right? And the surface is pointing up, right? And so this is the back side, this is the front side, and that information is useful for Rhino to sort of tell exactly what is enclosed and what is not enclosed, right? In making like closed reps and stuff like that. It's also good to know that these things have directions, in case you didn't know earlier. A lot of things have directions, like lines have directions, these surfaces have directions, etc. Where was I? Right, so B-reps are essentially that. They're a collection of surfaces. They can be closed, they can be open. Like, let's say if I were to join this together, and I were to ask what, it's a polysurface now, but it's an open polysurface with 3 surfaces. And this is also considered a B-rep. So B-rep is sort of, you know, just like a general sort of geometry term, okay? And even this is a B-rep, right? It's a sphere. And so the comparison to B-reps, we're sort of like the other side to it is the mesh. And so these things look very similar. I have to repair my box. I'm just gonna make a new box. Okay. Oh, I want to keep this box. Okay, let's go slow. These are like the exact same thing essentially, right? But they're really not, at least not to Rhino, because a mesh, this is a mesh. And what meshes are essentially, they're made out of multiple polygon faces, like triangles or rectangles, etc. So like when this sphere over here is converted into a mesh, you can see that it actually has sort of, it undergoes this sort of like pixelization process, right? So it can be a very fine sort of pixelization, like this, like where it's like a fine mesh. It's very, very well described. Or it can be like something rough like this, where like, you know, it has less faces, it has less of a resolution to it. And so the analogy I'm going to draw between breps and meshes is that breps are sort of like vectors, where they are mathematically precise representations of a shape, and meshes are like the raster version. They're like pixels. So like if like meshes are made in Photoshop and breps are made in Illustrator, right? So like I could scale this bad boy, this brep, like, you know, to whatever size I want, and the description of it is always going to be mathematically accurate. Like this, I'm never gonna like zoom in and suddenly be like, oh, I can see all the pixels, right? But for something like this, like even though now it looks really round, the moment I start to like, you know, make it extremely, extremely large, the resolution of it becomes apparent, right? There's a sort of pixelization that happens. And so that's sort of like the basic difference between breps and meshes. And they are both good for different things. Different programs use different ones. But for now, that's essentially all you need to know. And mostly we'll be using breps because meshes are a little bit tricky to work with. And breps, because they're mathematically precise, take less computing power to actually calculate sort of for intersections and for they're more easily manipulatable. Manipulatable. I cannot speak today. I'm sorry. And so, oh yes, so to convert breps to meshes, this is like super extra. You can essentially just type mesh on a brep, right? And it'll be like, oh, how fine do you want your mesh? You know, you want less polygons, you want more polygons, and then it'll give you a mesh, essentially. That's how you convert it. To convert it back to a brep is a whole different story. Like, it doesn't exactly work very well. There is a command called mesh to NURB, but it doesn't give you exactly what you want, because the brep that it gives you, so this is what it gives me when I ask it to convert it from mesh to NURB, is essentially like it converts each face into an individual surface, and then it like patches it together. It's not really converting it back to a brep, you know. And if it's something like this, it'll actually just blow up your computer. Like, this will just explode your computer. So I don't recommend it. There's like other programs you can try to do that with, or like to reconstruct it, but reconstruct things from meshes, but it's kind of tricky. Let's see. And so there's a bunch of basically different like basic solid types that you can create with Rhino. Like the plane command creates these planes, right? Like the box command, like stuff like that. It's like really basic, right? Like you just convert boxes, like cylinder, like it's literally like as the name describes. Like I don't need to teach you this, you can go figure it out. And if you don't know what's out there, you can go on like the Rhino website, or like you can just Google it. It's also like all here on the side, like you can see like pyramid and all this like random kind of things, and you can go figure it out there. Okay, I'll just leave that there. Another way to create solids, and this one's especially true for sort of I cannot brain today. either way, it's called lofting. And what it is basically you select curves, and it essentially creates a surface from these curves that follows the curves to the best of its ability, right? So you'll get a screen for loft options, and then you can sort of you can play around with it. There's like different types of lofts, so you can sort of see that my loft here is changing based on what I choose over here, right? You can play around with this. There is there is more depth to it, in that when you try to loft objects, when you try to loft curves together, the curves have seams where the curve starts and ends, and the curves also have directions. So you can see the arrow pointing to the direction, and you can see the seam where it meets, and essentially it'll try to match the seams together. Sort of think about it like if you have a piece of paper and you're trying to wrap it around like a cylinder, right? Like that's essentially the sort of operation this is, where it's trying to wrap it around and the paper ends have to meet at where the seams are. And sometimes that can give you problems, because if you want to loft something more complicated like this, sometimes maybe the seams are not like in the right place. Like maybe the seam is here and the seam is here or something. You know, like maybe it's like something like that, right? Like your seams are like wonky, they're all over the place. And so when you loft it, you get this like piece of like, it's just like twisted upon itself. And so you have to try to like align the seams together. But you can play around with it. There's a lot more depth to this command that I'm not really going to cover, but just know that it's there, and that's what it does. So the next thing we're going to talk about are Boolean operations. And Boolean operations are simple at the same time kind of complicated. And there's just the 4 basic ones, if I remember correctly. Yes, there's the 4 basic ones. So the first one is Boolean union. So we have a sphere and we have a rectanguloid box. God. And if you type Boolean union, it will essentially union these two. It will join these 2 objects together. Right now they're one object. The next one is Boolean difference. Right, so you choose an object to subtract from, and you choose an object to subtract with. And so you see that this box has had the circle cut out for it. It's really self-explanatory, really. There's Boolean intersection, and you just choose the 2 intersecting objects, and it'll find the area where they intersect, right? And then the last one is Boolean split, right? And Boolean split essentially actually just gives you, it's kind of like intersection. It gives you the intersecting area, but it also splits the 2 objects. Well, it splits this object from with this as a cutter, right? So this object is cutting this object, and you get the part that's intersecting in between. And the last one is you can do Boolean 2 objects, and you can click to iterate through the different Boolean results that you would get, right? And that's essentially it to Booleaning. Sometimes Booleans will not work. I'll give you this, like a lot of the times when using Rhino, you will run into issues with Booleans where maybe your geometry is like really complicated, or it's like your geometry is like just done in some weird way that's like, you know, there's too much geometry, or like you don't know what's going on anymore. You're trying to Boolean everything together into like one thing, but it just won't work, and it'll tell you Boolean failed. And there could be many reasons for that. There is a whole wiki page on the McNeil forums that goes through why Booleans could fail, and yeah, it's quite a lot. So you can always refer to that if you need help with why your Booleans aren't working. But I'll put a link to that below as well if you guys ever run into trouble. But some of the issues, and it gets like pretty mathematical. It's like, you know, you're trying to Boolean 2 things together, but like it looks like they're touching, but actually like they're actually just touching at the corner, and that's like literally impossible. Like it just won't, like it's just like they don't intersect. Like there's usually some sort of intersection problem, or you're trying to Boolean like a surface. This is not really a logic error, I guess. Like you're trying to Boolean a surface with a solid object, right? And this is where like the surface direction comes into play, because you see that the surface direction essentially chooses like the forward part to keep and the back part to dispose of, right? So maybe it's something like that and your object's not closed. Maybe you're trying to Boolean like an open object and a closed object together. There could be a lot of reasons, and you will learn with experience. But for now, that's like sort of a very basic way to like join things together. What is next? We can talk about edges. And so, I swear I have more to talk about. Oh, yes, no, actually, we should talk about something else first. My bad. We should talk about sort of other ways of creating solids. So, I will use this as an example. So, let's say you have like some sort of floor plan, and you want to make the walls, right? So, what you can do is you can essentially do Extrude Curve, and all this does is extrude your curves upwards, so like a certain height. But you can see that these are still surfaces, right? They're still open. And then you want to close it. You want to have solid walls, right? So what you can do is you can do cap, and cap basically closes whatever solid you have that's open, right? So like let's say if I were to do a rectangle, right? Just like as a demonstration, right? And I extrude this up, right? And then I cap it, you get a box, right? It just closes whatever sides that are open and planar. So if these sides are not planar, cap actually won't work. It'll just be like, how do you want to close this? Like, I don't know. Like, yeah, like it just wouldn't know how to close it. And so now you see we have like a bunch of boxes, and then you can just take the biggest one, and then you can sort of call out the, you can just do Boolean Difference, is what I did here. So I should just do this slowly. Boolean Difference. So you can see, I choose the object to subtract with, and then I choose the one. Did I cancel it? I am just all over the place today. I'm so sorry. But you choose the object to subtract from, and then you choose the ones to subtract with, and then ba-boom, right? You cut out these boxes from this big box, and then you have sort of your walls. And that's one way to do it. Another way is slab. There's a command called slab, and essentially it offsets the curve to one side and also creates it as a wall, right? And so essentially you just get this offset sort of wall, and you can sort of see like I'm choosing which side to offset it to, right? And so that's like another way to create walls essentially. For solid manipulation, there's also like a lot of the same ways you can manipulate curves and stuff like that. The same commands like work with solids as well. And it's good to mention that Boolean commands are actually like essentially 4 commands in one. Like everything you can do with Boolean commands can actually also be done manually. And they're sort of just a shortcut essentially. And so yeah, the same ways you manipulate like other objects like curves and stuff, you can use the same methods to manipulate solid objects, right? Like let's say I want to cut this box in half. I draw a line, and then I can do split. I choose the object to split. I choose the cutting object, and the line will actually just split it right down in the z-axis. And then so you have 2 halves of the box. They're open, and then maybe you want to close them. You can just cap them, right? That's one way to go about it. There's also trim, which I'll just use this here. And it's good to like have your objects that you're cutting using as cutters to be larger than the objects that you're cutting. Right, so if I want to trim this box, I just trim it like that, right? And then I'm left with the piece that was inside, right? I can close it if I want. So trim, split, explode also works. You can get it in like a bunch of different surfaces now. Join still works. You can join these together again, right? What else? Yeah, I think that's basically it. Like those like there's more ways you can manipulate solids if you want to be more specific about it, but those are like sort of the basic ways. That plus Booleans should get you through like most things. And then if it's like it's really specific, like if it gets into sort of furniture and stuff, and like how furniture has like, you know, they have like chamfered or like they have edges that are like rounded or something like that, there's 3 commands that you can use, and one of them is Fillet Edge. And so you choose the edge you want to fillet, and there will be a radius for it. And so the radius is essentially like how much the, the radius is essentially like a preview of how much the, I'm just gonna zoom in here. I don't know if you can see very clearly, but you can see like that's essentially how much it's gonna get rounded, right? And then when you press space to finish it, you get this nice rounded edge. So that's fillet. There's blend edge, right? And there is chamfer, which gives you the straight edge. Oh wait, no, sorry, it's not chamfer, it's chamfer edge. Yes. So there's chamfers. If you just use the command chamfer, it's for, I believe, curves and lines, but chamfer edge is for solids. Yeah, and so you get a chamfered edge. Okay, now let's talk about make 2D. So make 2D is essentially like if you have something like this. I'm just gonna get rid of everything else. I'm just gonna hide it. So make 2D is like if you have something that, you know, you model the house or your object in 3D or something. Now you want to make it a line drawing, right? You want to start messing with the line weights. Make 2D is essentially the way you do that. So you just highlight whatever you're trying to make into 2 dimensions, and then you just click make 2D. You name your layer that you want to go over. Like it'll make your line. It'll put your lines in a whole different layer. So we'll just put this as lines, and then you can choose a bunch of different options, right? There's like tangent edges. Like this little display screen will essentially tell you like visually how things change. And you can show hidden lines. You can choose not to show hidden lines. And group output is also like a really useful one. Essentially what group output does is that whatever lines comes out of each object, it will group those lines together and treat it as if it's still one object, essentially. And so if we make 2D this, right? You make 2D, it'll show up. You have to view it from the top, and it'll place it like somewhere on your. There's a certain logic to how it places it, but I don't remember how to describe it. But if you're like ever lost and you can't find it, like once you make 2D, I'm just gonna undo it. So if you make 2D, you make it, it draws it. Immediately after you make 2D, it's actually, your lines are actually selected. So you see that this is actually selected if I go to the top view. But like if I go to the top view and for some reason it's like really small and I can't find it or something, it's already selected. You just don't click and then you just do ZS, which is zoom selected, and it'll zoom you right to the lines. And here you can see that like I still have the hidden lines on, but essentially each thing is treated as one object here, right? And sometimes you'll run into issues like this where if you look from here, these 2 squares are like inside one another, but it's drawn as if they're sort of like they're separate objects, because they are separate objects, you know. And this is something like if you weren't into this, like you would have to like highlight both of them, and then you do like trim, and then like you're like, oh no, like please join together. I want you to look like one box, right? I shouldn't have turned on hidden lines. Oh no. Right, like you're trying to like manually join into one box or something, but there's no need to do that. You can, like in times like that, you really should just watch out and like join your objects together, right? And once they're one object, then you can make 2D that object and it'll show up as one object, right? And so okay, let's get everything in there. Okay. And so in the make 2D, under your layers, you'll see that. Oh, okay, I don't need that. So under the layers that we bake the lines to is this layer called lines, and underneath it there's like 2 sub layers, right? There's hidden and there's visible. So hidden is just the hidden lines, and then curves are just the visible lines. It's really as simple as that. And then to export it, let's say if you want this to be a certain scale. I'm not sure how large this object is actually. I'm just gonna distance. It's like 50 millimeters high, and maybe we want to draw it on a piece of letter sized paper, which is 8.5 inches by 11 inches. And you can just type the unit into the command bar and it'll give you that unit, right? And so like I draw the paper, and then, I mean, this is 1-to-1 scale right now, and it's looking pretty good. Maybe I want something smaller. Maybe I want like 10 of these or something. And so I can just do scale, and then to do it like 1-to-10 scale, let's say like if I want to do 1-to-10, I just do 1/10, right? Sorry, I should have just said like I do scale. I click on the base point to scale from, and then I do 1-to-10, right? And then like, you know, maybe I want to do like I want to do a cool grid of these or something. So cool. Anyways, yeah, that's essentially how you scale, and then you can just export this entire thing to Illustrator. I should show it. I keep putting stuff on my other monitor. Don't name your stuff like that. You'll never be able to find it. And then so it's right here. I'm gonna open it in Illustrator, right? And you can see your drawing over there, and it maintains the layers, right? So you still have your layers that from before were hidden, your hidden lines, and you also have your visible lines, right? And so maybe I'll try to make this a little clearer by changing maybe it's not dashed. I'll change the color. Right, so you can see that you still have your hidden lines, and you still have your visible lines, right? And you can choose whether you want to show them or not. You know, maybe you just want to show that. Oh, I forgot one more thing. Also, if you want to do like outlines, you can do like mesh outline, and then you'll have essentially it'll make like an outline of your object, and then you can use that to make 2D, and then I'll name this like outline or something. Right, and so now I have like an outline of the object from before. Oh no, I've already moved those. Okay, I'll do another one. And it's also really important to know like your angle of your camera when you're make 2Ding, because if I were to shift my camera here, I wouldn't be able to get this exact same view ever again, right? Like it would be so difficult, and then my lines just wouldn't match up if I were to make 2D again from this like different angle. What you can do is you can go to the named views tab. Under panels, there's named views, and then you can save this view, right? This current perspective, I'm gonna save it as perspective. And so like if I were to like rotate my camera, and here you can see the mesh outline, and mesh outline basically outlines it, but it's only from that angle, right? Like, see, like I can't get that angle back again. And then it makes 2D, and then when you make 2D the mesh outline, it makes it flat. But like I can't ever get that view back again. So you just save it to a named view, and then you double click it, and you get exactly that view. And that way you can sort of, you know, make 2D drawings, and then realize you forgot something, and you need to make 2D it again, but then you come back and you're like, oh no, like I can't get my view back. Tragedy. But now that won't happen to you. And so I have my outline, right? And I have my other curves. I'm just gonna export it again, and we're just gonna have it nice and large this time. Let's get rid of this old one, right? And so you have your artboard, and I'm going to make my artboard the size of the paper that I want. Oh, there it is. Right, and then I'm just gonna move my paper onto it, right? You know, get it, you know, however you want. You can position it on there later. I don't even need the paper like line anymore. The outline. I don't know what this is. And so from there, you can do your drawing. So maybe I want the outline to be thicker, and I want like the interior lines to be sort of like thinner. Right, and so like you have this sort of nice like thick outline, right? And then you have your really light like interior lines. Like maybe I'll make my outline like 5, and then I'll make like my interior lines like 3, and then my hidden lines can be like 0.15, but then I want it to be like, well, there's more of a, I want it more like, more fine, right? I can edit the dash and the gap, and it's missing a line here. Yeah, it is missing a line here. Where did that go? Anyways, and then there you have like a nice line drawing, right? And then you can just write in your skill and stuff as well. Yeah, that's it. That's basically it for today. I have one more little workshop, I guess, on like advanced Rhino tips and stuff coming soon. Yeah, let me know if you guys have any questions and stuff as well.